So example 2, find the following key features of the function, then sketch a graph. So same concept. F of x equals 2x to the fourth minus 10x cubed minus 2x squared plus 10x. Okay, so for the y-intercept, this is in standard form now. So when it's in standard form, we look for the constant, which there's no constant at the end. That would mean that it's 0. So our y-intercept is going to be 0. Another way of thinking of it is you can find it the same way. Like you can find f of 0, but if I put in 0 for all of my x's, this is 0, this is 0, this is 0, this is 0, everything cancels out because you're like multiplying something by 0, so it all cancels out, and it's just f of 0 is equal to 0. I'm going to go ahead and write it out like manually so you could see. It'd be 2 times 0 to the fourth power minus 10 times 0 to the third power, and then minus 2 times 0 squared plus 10 times 0. So 0 to the fourth is 0 times 2 is 0. 0 to the third, 0 times negative 10 is 0. 0 squared is 0 times negative 2 is 0. And then 10 times 0 is also 0. So all of that is just 0. So we end up with f of 0 equals 0. So we have a y-intercept at 0, 0. Also means that's an x-intercept as well. Okay, and then to find the zeros of the function, same concept, we put 0 in for like all of f of x. So it'd be 0 equals 2x to the fourth minus 10x cubed minus 2x squared plus 10x. And then I'm trying to solve it, so I'd solve by factoring. It's already factored. When we factor, we want to check for GCF first, which all these terms have a common factor of 2 that I could definitely divide out, but they also all have like a common factor of x that I can pull out as well. You can technically divide out the 2. You cannot divide out the x though, so I'm just going to leave it as like 2x as my GCF. You can never divide out an x because it eliminates like one of your solutions, so just keep that in mind. So if I factor the 2x out of the 2x to the fourth, it would leave me with just an x to the third power. And then negative 10x cubed divided by 2x would be negative 5x squared. And then negative 2x squared divided by 2x leaves me with negative x. And 10x divided by 2x leaves me with a plus 5. And then now inside that parentheses, I have 4 terms, so I'm going to have to use factor by grouping. It's really important that this negative 2x does not disappear, though. It has to stay there the entire time. So I don't know if I said negative 2x. It feels like I did, but it's just the 2x out in front has to stay in front the entire time. So it'd be 0 equals 2x. And then inside the parentheses, I'm going to cut this in half to use factor by grouping. So from the first half, x cubed and 5x squared, I'm going to put some brackets up here to kind of separate between the different parentheses. Between x cubed and 5x squared, the GCF is x squared. When I pull that out of x cubed, it leaves me with x to the first power. When I divide it out of the negative 5x squared, it leaves me with negative 5. And then the second half, negative x plus 5, I'm going to factor out a negative because I want to flip the signs. I don't have a GCF other than 1. I'm just going to factor out a negative 1. And even if I didn't have to factor out a negative, I would still like write it as like factoring out a 1. I would just do a positive 1. But I need to flip the sign, so I'll do negative 1. When I do negative x divided by the negative 1, it turns it into a positive x, and the positive 5 divided by negative 1 turns into negative 5. And then now what I have inside the parentheses is the same. That's good. That's what I needed. And then what I can do, I'm going to keep this like 0 equals 2x out in front. And this, this is basically created 2 terms, one right here, and then one right here. And they both have a common factor of x minus 5. I pull that x minus 5 out of each, and then the remaining like parts become their own binomial factor. So x squared minus 1 becomes its own binomial factor, and it goes in its own parentheses. You want to make sure that you have factored something like completely. Technically, this x squared minus 1 can be factored further because it's a difference of squares, because 1 is the same thing as 1 squared. So using the difference of squares pattern, I'm going to write that up here. That's like my a squared minus b squared factors into a plus b times a minus b, something we use throughout the year. So this becomes 0 equals 2x times x minus 5. So that whole like kind of first part stays the same. And then now I'm going to go ahead and factor the difference of squares. So x squared minus 1 squared would factor into x plus 1 times x minus 1. And then now it's factored completely. So right here at this point, it's factored for as far as it can go. Now I can set each factor equal to 0. So I would do 2x equals 0. And then x minus 5 equals 0. X plus 1 equals 0. And x minus 1 equals 0. Okay, so for 2x equals 0, I would have to divide both sides by 2. And then I would just get x equals 0 as one of my zeros. For x minus 5, I would add the 5 over and get x equals positive 5. For x plus 1, I would subtract the 1 over and get x equals negative 1. For x minus 1, I would add the 1 over and get x equals positive 1. So I have an x equals 0, x equals 5, x equals negative 1, x equals positive 1. Okay, and then for the x-intercepts, it's those numbers, I just have to write them as x-intercepts, like as points. So it'd be 0, 0. If you have a point 0, 0 that's exactly on the origin, it's an x and a y-intercept. And then 5, 0, negative 1, 0, and 1, 0. It's all of my x-intercepts. Okay, and then moving on to end behavior. So to figure out end behavior, we just have to look at what the lead coefficient is and see if it's positive or negative. Lead coefficient is the number that's in front when it's in standard form, so ours is 2. It's positive, so that means the function is increasing overall. That means that since this is a quartic, it has like an even degree, both sides would finish going upward like a positive quadratic. So no matter what, like for quartic, it's degree 4, so it's either going to be both up or both down. Since our lead coefficient was positive, it's both up. Okay, so if both sides are going up, it means both f of x's are going to go to positive infinity. So this is as the graph goes left, it goes up. This is as the graph goes right, it goes up as well. So up on both sides. Okay, I'm going to go ahead and start sketching the graph now so we can get positive and negative, then relative max and min from that. So I have zeros at 1, negative 1, 5, and 0. So I'm going to make my like positive x-axis a little bit bigger. So I have to go like all the way up to 1, 2, 3, 4, 5, and then I just need to go down to 1 on like the negative x-axis. That's my smallest one. And then I can go ahead and plot my points. So I have a 0 at 0. Hold on, this is like pretty like off, so I'm going to try to make it a little bit more even. Okay, that feels a little bit better. Okay, so I have a 0 at 0. I also have a y-intercept there, same thing. And then x equals 5, that's another. X equals 1 is another. And then x equals negative 1 is another as well. So this will be positive 1. This is negative 1. And then we want to check the multiplicity. So to do that, I have to go to factored form, which is down here. And then I see what power each factor is being raised to. None of them have exponents, so they all are raised to the first power. So that means that they're going to cross through at each of those intercepts as opposed to like bouncing off. So then I go to my end behavior, and okay, I say the left side is going up and the right side is going up. So from my leftmost point, my leftmost x-intercept, I'll go upward. For my rightmost point, my rightmost x-intercept, I'll go upward as well. And then I'm going to cross through each x-intercept. So I'm going to go ahead and label this as a 5. And then this is 0. I'm going to cross through, like starting right here. I'll cross through at -1, turn back around at some point, cross through at 0, turn back around at some point, cross through at 1, turn back around at some point, and cross through at 5. So again, it's like a sketch, so it's like we don't have the exact points, but this is like the shape of the graph essentially. So from this, we can figure out what is like where the function is positive or negative. Even if your graph looks different than mine, it should be like positive and negative in the same exact spots. Yours is just like maybe like going up higher, going down lower, but the idea is the same. So for positive, it is positive right here, and right here. So that far left section, it is positive until it hits x equals -1, and it's everywhere to the left of that. So that would be -infinity to -1. This middle section, it's positive between x equals 0 and x equals 1. And notice I'm always like using the x-intercepts as my boundary lines. That will always be the case for this type of problem, like looking at positive and negative. So 0 to 1 is that second region, like from here to here. And then it's positive, like starting right here and then all the way to the right. So starting at 5, and then to the right of 5 would be to infinity. So notice like anytime I say like all the way to the right or all the way to the left, it just keeps going, and that interval involves infinity. So keep that in mind. Okay, so where is it positive? We just wrote the 3 intervals. I'm just going to copy them down here. It's -infinity to -1, 0 to 1, and then 5 to infinity. And then next we'll do negative. So it's negative down here and then down here. So this first section is like it starts being negative at -1 and it stops being negative at 0. So it would be between -1 and 0. And then the second section right here, that starts being negative at 1 and stops being negative at 5. So that would be between 1 and 5. And then next we can talk about relative max or min. So every point where it changes direction is going to be either a relative max or a relative min. Hold on, sorry, I'm just trying to clean this up a little bit. So we have a change of direction right here, and right here. We can estimate each of those values. So we'll start with the max. We'll do this one. So that is happening like between 0 and 1, between x equals 0 and x equals 1. So let's say like 0.5. And then to find what the height of that point is, I would have to substitute it into the function. So I would have to do f of 0.5 is equal to 2 times 0.5 to the 4th power minus 10 times 0.5 to the 4th. And notice I'm putting into like the original function, nothing like of what I have over here, like after I factored out GCF. I mean, you technically could. I don't know if it would save you any work or anything. If I had divided out the 2, then we could have no longer done that. And then for the next part, it's negative 2x squared, so 2 times 0.5 squared. And then the last is plus 10x, so 10 times 0.5. Okay, so if I do 0.5 to the 4th, this is, I should have grabbed a regular calculator for this, but on like if you use like an iPhone calculator, you have to use the like you have to turn it sideways, and then you have to go, there's like a button in the second row towards the middle that has an x to the y. That's how you pick like any exponent. So we do 0.5 and then x to the y and then hit 4, and that'll give you what like 0.5 is to the 4th. And you could also, it's probably a little bit easier on like a Google calculator as well. So 0.5 to the 4th is 0.0625, and then if I multiply that by the 2 that's out in front, it'd be 0.125. And you could honestly type this like all in at once. If you just like Google calculator, it's probably best that way. And then if I do 0.5 to the third, it's 0.125, and then if I multiply that by the negative 10, it's negative 1.25. If I do 0.5 squared, it's 0.25 times negative 2, would be negative 0.5, and then if I do 10 times 0.5, that's 5. So then now I can add all those together, so 0.125 minus 1.25 minus 0.5 and then plus 5 is 3.375. Okay, so the y value at this point is 3.375, and then that's going to be a local maximum or relative maximum because it's higher than the point surrounding it. So there's a relative max at that 3.375 value. Okay, and then we have two more to find. And then we have two relative minimums. So we have one that's right here. It's in between like -1 and 0, so we'll say it's negative 0.5. I think I'm just going to copy this first line down just to save a little bit of writing time, and we'll just incorporate the negatives. So same function, we're just substituting in a negative 0.5 instead of a positive 0.5. So this would become a negative, this would become a negative, this would become a negative, and then this is a negative as well. So if we do negative 0.5 to the fourth, that's going to be the same thing. I think it was like 0.0625 since it's like you're raising it a negative to an even power. So negative 0.5 to the fourth is 0.0625, and then if I multiply that by 2, it's the same thing as before. So 0.125, and then negative 0.5 to the third power, that will be negative, so it's negative 0.125 times negative 10 is going to be a positive 1.25, and then negative 0.5 squared is positive 0.25 times negative 2 is negative 0.5 again, and then 10 times negative 0.5 is negative 5. So now we'll add slash subtract everything, so 0.125 and then plus 1.25 minus 0.5 minus 5 is negative 4.125. So that's the y value at this point. I'm not sure why I closed the parentheses, but the y value at that negative 0.5 point is negative 4.125. And we just care about like the height of that point. So that's going to be a relative minimum because it's lower than the points surrounding it. Okay, so relative minimum at negative 4.125, and then unfortunately, not, okay, I shouldn't say unfortunately, we have one more to find. I'll probably end up cropping this like example out and adding it as an extra example because it is pretty long. Okay, so we have one more. I'm gonna just go ahead and erase the work so far for our local or relative maximum, just so I have a little bit more room, but remember you can go back to the video if you need to see it later. So we have one more relative minimum that's like about right here. We can say that is like at approximately x equals 3, so 3 comma something. To find what the actual like height of the point is, what the y value is, I have to plug that 3, substitute that 3 into the function. So it'd be f of 3 is equal to 2 times 3 to the fourth power minus 10 times 3 to the third power minus 2 times 3 squared, and then plus 10 times 3. And again, like, you don't have to pick x equals 3, it just has to be between 1 and 5. So 3 to the 4th is 81, and then if I multiply that by 2, it's 162. 3 to the 3rd power is 27, and then if I multiply that by negative 10, it's negative 270. 3 squared is 9 times negative 2 would be negative 18, and then plus 30 at the end. So 162, and then minus 270 minus 18 plus 30 is negative 96. Okay, so definitely not the scale, but that's why we like actually put the number in to find what the maximum and the min is. So our output was negative 96. That's the y value at this point. It's lower than the point surrounding it, so that is a relative minimum. So we have a relative minimum at negative 96. And again, just approximations, there could be other points around it that are like slightly above or slightly below, but this gives us a good idea of like the shape of the graph.